Okay, this is lesson 2C, applications of graphing equations with two variables. Keeping in mind that we already learned about slope, y-intercept, and x-intercept, and how to use those to graph a line from an equation. Now we have to be able to write the equation from the word problem and then determine from the equation how to graph the line. So let's start with this one. Harold the hiker was already 4 miles into his journey when he realized that he needed to keep a pace of 2.5 miles per hour so he could make it to a next checkpoint on time. Write an equation to represent the total number of miles that Harold would hike after X hours. Okay, so there's a couple of key things here. One of them is this 2.5 miles per hour. So that is a rate. And usually, not all the time, when we have a rate like this, that's our slope. Now, sometimes when you read a word problem, you'll see two things that look like rates, in which case we'll have to take that one as it comes. But on this one, this is the only rate we have in the problem, and it's 2.5 miles per hour. The other number that we have in the problem is that he already hiked 4 miles. So if y is the total number of miles hiked, and he's hiking for X hours, one of the most important things that you should know about rate is this little formula, distance equals rate times time. This becomes very handy. See, if the rate is 2.5 miles per hour and the time is X hours, that becomes our M and the X. And remember, Y is the total distance hiked, so distance equals rate times time works in this case. So we have Y equals the M, the rate, 2.5 miles per hour for X hours, but that adds on to the number of miles he already hiked, which was he already hiked 4 miles. So this 4 was the beginning of what his, refiguring out his rate that he had to hike. So this is the beginning. It's not the beginning of the hike, it's the beginning of where he decided that he needed to keep a pace of 2.5 miles per hour. So there's our equation. So if we want to graph Harold's distance and time, remember X is the time, Y is the distance. You could make a table like this, and that would be perfectly okay. Or you could use the slope and the y-intercept. So if we use the y-intercept, remember the y-intercept is the y value when x is equal to 0. So if you put 0 in place of the x, 2.5 times 0 is 0, plus 4 is 4. So the y-intercept is 0, 4. And that conveniently fits on our graph right here, 0, 4. If the slope is 2.5, then you can make that a fraction as 2.5 over 1, or 2.5 is 2.5, and 2.5 is 5 halves. So that would be a rise 5 and a run 2. A rise over run. So if we do that, rise 5 and run 2. Rise 1, 2, 3, 4, 5. Right. So 4 plus 5 is 9 over 2. Look at how we're counting the hours. So over 2 would be all the way over 2 here. So if that's too confusing, then make an XY table. And you can say, well, what if x is 0? Y would equal 4 because 2.5 times 0 plus 4 is 4. What if x was 2? 2 times 2.5 is 5. 5 plus 4 is 9. So 2, 9 over 2 up 9. What if x was 4? 4 times 2.5 is 10. 10 plus 4 is 14. So 4 and 14, and hopefully that'll be on that same line. Looks like it is. And if we graph that line, nice straight line, then we'll have the graph of Harold's hiking starting at the 4 mile mark at 2.5 miles per hour. There you go. Let's try another one. So in this one, the city was setting aside some property for a park with a bicycle and jogging path around the outside. The park is to be rectangular, and the distance around the outside is 1,600 meters. And we have to find all possible dimensions of the rectangular park by graphing the equation for the perimeter. Okay, so there's a hint here. We need the equation for the perimeter. So remember back to formulas? You have a formula for the perimeter of a rectangle. So that's P equals 2L plus 2W. Okay. And it says the distance around the outside is 1,600 meters, so that we know the P is 1,600. So that gives us now 1,600 equals 2L plus 2W. And we have, let's let L and W be the X and the Y, because we need to find the length and the width. We don't know them. We have a coordinate plane over here with an X and a Y axis, so let's use X and Y for that. Let's let X be the length and Y be the width. So that would be 1,600 equals 2X plus 2Y. And we can graph that. Now, what is the best way to graph that? You have choices. While you think about that, I'm going to label this. So X is the length and Y is the width. Okay. So I decided to use the x-intercept and the y-intercept. Keep in mind that the x-intercept is the x value when y is equal to 0. So if y is equal to 0 in this equation, then 2y equals 0, and then we have 2x equals 1,600. So divided by 2 gives us x equals 800, so the x-intercept is 800. So in the x direction, we have to count all the way out to 800. That's our x-intercept. Let's count by 100s. 100, 200, 300, 400, 500, 600, 700, 800. Let's put a dot there on 800 because that's our x-intercept. Let's find the y-intercept. Remember, the y-intercept is the y value when x is equal to 0. If x is equal to 0, then 2x is also equal to 0, and all we have left is 2y equals 1,600. And if we divide by 2, then we get y equals 800. So the y-intercept is also 800, so let's count by hundreds. 1, 2, 3, 4, 5, 6, 7, 800 right there. And if this is a straight line graph, and we have those 2 points, 800 for the x-intercept and 800 for the y-intercept, we should be able to draw that line from the x-intercept to the y-intercept. See if I can get a straight line there. Yep. And that will be our line. Now, this problem doesn't say just graph it. It says find all possible dimensions of the rectangular park by graphing. So let's make a table. And our XY table will be the length and the width. So let's find some points on the graph. I might have to erase a little bit of this to make some room. Okay. So let's see what we have. If the length is 100, well, I'm not going to include 0 and 800 because you can have a length of 0 for a rectangle. Now, there are other solutions here, but let's stick with the hundreds. So if the length is 100, then the width would have to be 700. So there's a solution. If the length is 200, then we have this point, and the width would have to be 600. 200, 600. If the length is 300, then the width would be 500. You see the pattern there. Every time we go up 100 in the length, we have to come down 100 in the width. So 400, 400, 500, 300. 600, 200. Because they all have to add up to 800. Because if 2L plus 2W equals 1600, that means L plus W equals 800. So 700, 100. And that's not all the possible lengths and widths, but that's a pretty good number of lengths and widths that we can use. Okay, very good. Let us continue. We don't have very many of these, so this should go pretty quick. A humidifier has a tank that can hold 6 liters of water and can disperse water at the rate of 1/2 liter per hour. Write an equation to model how much water is left in the tank after X hours. So in this case, we have another rate here, liters per hour. So that's our rate. And if the tank is full at the beginning and it can hold 6 liters of water, that would be at the beginning amount of water in the tank. So write an equation to model how much water is left in the tank. So you're reducing, because you're dispersing water, you're reducing the amount of water in the tank after X hours. So if Y represents the total amount of water left in the tank, water left in the tank, that's the Y. And it starts at 6 liters, starts at 6, but it's going down negative 1/2 liters per hour. This is our, remember rate times time again? Rate times time, liters per hour, multiplied by the number of hours. So X is the number of hours, so that would be 1/2 liter per hour times X hours. Now, if you want to put that in slope-intercept form, you can just rearrange that a little bit to say negative 1/2 X plus 6. So either way would be fine. And then we want to create a table and graph that to show how much water is left in the tank. So since we have to create a table, an XY table, let's label the X and the Y, hours, and liters left in the tank. And I think it's okay to use 0 hours. At 0 hours, there's 6 liters left in the tank. For every 1 hour, we're losing 1/2 liter, so that would be 5.5. So 2, go down another half, 5. If you want to just keep the Y values as whole numbers, then count by 2s. So you could skip 3 and go to 4. So 4. 6, go down another liter, so 3. See what's happening? So every time I'm going to skip the 1 and 5.5. When I go from 0 to 2, I increased by 2 hours, and I went down by 1. See, the change in Y over the change in X is negative 1/2. That's our slope. So if I go down 1 more, well, actually up 2 more hours, plus 2, and down 1. Okay, and the same pattern continues. So to graph that, we could start at 0.6. It's already labeled for you here. And then we can go down 1/2. Or if you prefer, you could go in the X direction for every 1 hour down 1/2. That would be okay, and that would be right there in between. So just follow that pattern. And that's about as far as I can go. Let's see if we can draw a nice straight line. Ooh, that's really straight. Come on, straight line. Okay, that's not going to give me a straight line, so let's try that again. Okay, here we go. And it keeps on going until it's empty. So, hey, when will it empty? I didn't ask that. So, when will the tank be empty? So, when the tank is empty, the amount of water left in the tank would be 0. when is asking like how many hours, and that's x. So I'm looking for x when y is equal to 0. So if I'm looking for x when y is equal to 0, I would have to solve 0 equals negative 1/2 x plus 6. If I add 1/2 x to both sides, I would have 1/2 x equals 6. And then I would multiply both sides by 2 to cancel out that multiply by 1/2 to get x equals 12. So even though I can't see it on my number of hours here, it's going to go all the way to 12 when we get to 0 liters of water left in the tank. Okay? Oh, very good. All right, let's try this one. When a principal amount P is invested in an account paying simple interest at a rate of R% after T years, the account balance can be found with the equation. So we have another one with an equation. And there's two versions of this equation, A equals P plus PRT. You might remember I equals PRT from our simple interest equation. But this I equals PRT only gives you the interest earned. So to find the actual balance in the account, you have to add how much you invested plus the interest earned to get the actual balance. And so that's why this equation is P plus PRT. Now, for those of you who remember factoring out a greatest common factor, you have a greatest common factor of these two terms of P. And if you factor out that P, then you have 1 plus RT. And that's how we got that equation. So I kind of like this equation here for simple interest. So we're supposed to graph the account balance each year for X years when $100 is invested in an account paying a 5% simple interest. So let's write the equation. So we're going to graph the balance each year. So that would be the A. So we're graphing the A equals, and when $100 invested account, so that would be 100 times, so 1 plus R, 5% is 0.05. And X years, T is the time in years. See up here, T is the time in years. So we're going to put X in there in place of the T. So 0.05, oh, I didn't leave room for my X in there. So let's put the X in there. And there's our equation for that one. Now, if you use the other equation, A equals 100 plus 100 times 0.05 times X. You could use that too. And then it would look like this. 100 times 0.05, we can go ahead and multiply those, and that would be 5x. So it's really 5x plus 100, which I guess is easier. A, that's our y right there. And so we could write this as 5x plus 100. So let's graph that and see what we get. So we have A, or y, equals 5x plus 100 in simplest form. So that would be our y-intercept. Because we're depositing $100, that would start at $100. And I have already got some numbers in here for the x. Remember, x is the time in years. And the y is the balance on the account. Okay, so according to this, we have to go up $5 every time x increases by 1. The slope is 5 over 1. So $5 every 1 year. So this is 1 year, so we have to go up $5. It's really hard to tell where going up $5 is. So let's skip ahead a few years, and if we were making a table for that, X, Y table, so that we could actually graph it. So 0, 100. Let's go to 10 years. So in 10 years, this would be 5 times 10. That'd be 50 plus 100. That'd be 150. 150. I can tell about where that is. Let's go to 20. 5 times 20 is 100. 100 plus 100 is 200. Look, every time we go up 10 years, we're going up $50. 2,200. Let's go to 30. 5 times 30 is 150 plus 100 would be 250. 30. Oh, 250. Let's see. Oh, I almost have room. 3250 would be about right there. Okay, so let's go ahead and draw that line. Nice straight line. All those points end up on that line. Awesome. So, and we could use that graph to find out our balance at any number of years. Now, in the next problem, we have compound interest. Notice the compound interest has a different formula. A equals P times 1 plus R to the T power. So that's different. So we have an exponent here that we didn't have in the other one. And since T is years and X is going to be the years, then when we turn this into an equation with Y and X, X is going to be the exponent. So A, or Y, the account balance, that's the account balance A. We're depositing $100. Now we have this 1 plus R. R is still 5%, so 0.05 in parentheses to the T power or to the X power. Now we could go ahead and add these together because that's the only thing in the parentheses is 1 plus 0.05. So we can make that 1.05 to the X power. Okay. Now in this one, graphing that, okay, Y equals, oh, there it is. Let's make a table and see what we can come up with here. So X and Y. So 0, 100 still. Remember how we went out to 10? All right, so let's do that. So Y equals 100 times 1.05 to the 10th power. Now, keep in mind, you're not multiplying by 10. You're taking 1.05 to the 10th power. I'm going to use my calculator for that. 1.05 to the 10th power. And then don't forget to multiply that by 100 times 100. I got $162.89. Okay, let's try 20. So I'm going to put 20 in place of the X here. So it's going to be 1.05 to the 20th power. Then don't forget to multiply by 100 for our principal. I got $265.33. Okay, let's try 30. Because I think we have room for that. So 1.05 to the 30th power. 1.05 to the 30th power. And then don't forget to multiply that by 100 for our principal. $432.19. Now in this one, we're starting at 0, 100, just like we did before. 10 and 162, so 125, let's see, these go by 20s. 20, 40, 62, so that'd be about 162 right there. Because that's 20, 40, 60, 80, 200. Okay? 20, 265, 20 and 2, 20, 40, 65, and 30, 432. 30, 420, 32, about right there. Now, question, are these points in a straight line? Let's see if I can get a straight line here. Yeah. Okay, now if I draw the straight line between the first 2 points, the other 2 points are not on that line. If I draw the line between the first point and the third point, the other 2 points are not on that line. And when I draw the line between the first point, the last point, the other points are not on that line. This is nonlinear, so we're not going to draw a line. It's nonlinear because we have an exponent, and not only that, x is the exponent. This is an exponential function. Now we're going to kind of sketch the graph so we can see what it looks like, but it's got to be a curve that goes through this point and then through this point and then through this point. And it might be kind of hard to tell that it's curved because of my freehand drawing there, so let's get a better graph of that. So here is a better graph showing you the difference between the compound interest, which is this one, that's the exponential function. That's the red one. And the simple interest, which is linear. So now you can see the difference there. Okay, so we're not really getting into graphs of exponential functions in this class or any other kind of nonlinear functions, but I just wanted to point that out. When we have an exponent in an equation, chances are it's not going to be a linear equation and the graph is going to look different. You can't just plot 2 points and draw a straight line. See, we needed to have all of these points so that we could determine that we didn't have a straight line. Okay? So hopefully that will help you get started, and good luck with the assignment on those word problems.